So let alpha, beta, and gamma be the roots of the cubic equation x cubed minus 7x squared plus 3x plus 2 equals 0. If the cubic equation x cubed plus px squared plus qx plus r equals 0, for some integers p, q, and r has the roots alpha plus beta, alpha plus gamma, and beta plus gamma, find p plus q plus r. Yeah, this has something to do with Vietas. So I'll just give you guys a starter also. This problem is actually pretty nice in terms of getting the values. I'll show that in a while. To give you guys a starter, the sum, for those who know Vietas, what is the sum of the roots here of the original equation? So what is alpha plus beta plus gamma? Yeah, it's 7. So essentially we just get it from here and then negate the coefficient, right? So this is 7. Alpha, then what is alpha beta plus beta gamma plus gamma alpha? So it's 3. And then lastly, alpha beta gamma here is -2. So I'll just give like a brief introduction for those who don't know how where these came from. So the 7, the 3, and the 2 came from these coefficients. So notice that since the cubic is monic, we can simply get the coefficients. However, the signs alternate between negative and positive. So, for example, for the first one, we have to negate this. We have to negate the -7, so that it becomes +7, and then the second one we don't have to negate it, and then the last one we do. And notice that the expressions we get here have degree 1, degree 2, and degree 3. So basically, this just the sum of the sum of the roots, then the pairwise products, then the product of all three. So if we have higher dimensions, it will just be product of one root, product of two roots, product of three roots, and so on. So I'll let you guys think first about the actual question for maybe for a few minutes. Yeah. Uh, so basically, the what we're looking for using the same technique kind of is the following. So P is just the negative of the sum of the three new roots. So that's just alpha plus plus beta plus gamma plus alpha. And so if you simplify this, this is already pretty straightforward. So this is -2 times alpha plus beta plus gamma. So what is the value of P for this one? Let's see. So from here, we get that the value of P is -2 times 7 equals -14. So essentially, we just substituted this one that we already have. Okay. Now let's go for Q, which is slightly more complicated. So this time, since this is the second sum, we don't have to negate. And so this is just the sum of the pairwise products. By pairwise products, by the way, we mean the products of of any two of the roots. So in this case, that would be alpha plus beta times beta plus gamma plus beta plus gamma times gamma plus alpha. And then lastly, uh, yeah, then gamma plus alpha and alpha plus beta. So notice that if you expand the first product, you should already see something coming. Um, if I expand this one, then I get, I'll do this by FOIL. This is alpha beta plus alpha gamma plus beta squared plus beta gamma. And I'll give you guys a tip. Notice that the entire expression is symmetric. So basically, if I expand the first product, I already know that the other two products will look like this. And that can already tell me what the entire thing looks like. And so I can say that since there's a beta squared here, I also know that there's a gamma squared and there's an alpha squared. So I can already write the first part of the expression as alpha squared plus beta squared plus gamma squared. And then now we account for the other three terms. If you expand the other two products, there's also you will also see these terms appearing. So that is 3. So the entire thing is just 3 times alpha beta plus beta gamma plus gamma alpha. There's a question here. How do I tell if it's symmetric? Basically, the definition of symmetric is if you switch any two of the variables, then the expression should still be the same. So for example, here, if I switch alpha and beta, then this then the expression will become beta plus alpha, then alpha plus gamma, and then plus alpha plus gamma, gamma plus beta, and then lastly, um, hold on. And then, but you get the idea. Um, Essentially, if you do that, then the expression should still be the same. If you work with enough symmetric polynomials, then you could then at some point you can get this feeling that something looks symmetric just by looking at it. Hold on. Yeah, so what Philip and Ethan Choi said also. Yeah. Okay. Now, if we look at this expression, we're still not completely done because we have alpha squared plus beta squared plus gamma squared, which is not that straightforward to find. And so, um, what we do is, yeah, use the square of a trinomial. So what we do is we rewrite this as alpha squared plus beta squared plus gamma squared plus 2 times alpha beta plus beta gamma plus gamma alpha plus this thing again, right? And notice that these terms form the square of the sum of the three. So that's alpha plus beta plus gamma squared. And then we add in the final plus alpha beta plus beta gamma plus gamma alpha. Okay, and then evaluating this is pretty straightforward now. So that's 7 squared uh, plus 3, which is 52. I'll zoom out a bit. Okay. Lastly, we go to R. Okay. So R in this case is the product of all three of the new roots. So this is alpha plus beta times beta plus gamma times gamma plus alpha. Okay. Notice that actually an easy way to uh, evaluate this is to notice that we can rewrite alpha plus beta as 7 minus gamma. Why is that? You can get it from here. Just subtract gamma from both sides, right? And so using this, we can rewrite this entire expression in a way that's more manageable for us. So that is 7 minus gamma, 7 minus beta, 7 minus alpha. Okay. And expanding this, I'll just spare the expansion for you guys. 343 minus 7 squared, 49 times alpha plus beta plus gamma. Okay. Plus 7 times alpha beta plus beta gamma plus gamma alpha minus alpha beta gamma. You probably noticed that if we substitute this one here, then this entire thing cancels. So we can also get an identity here that this one is actually equal to alpha plus beta plus gamma times alpha beta plus beta gamma plus gamma alpha minus alpha beta gamma. So just something worth noting. But I wouldn't really recommend memorizing it also because deriving it is pretty easy if you know this transformation. So yeah. If we substitute everything here, this is 343 minus 49 times 7. As I said, this will cancel out. And then plus 7 times 3. Then minus negative 2. So this is 23. Okay, cool. And therefore, since we're asked for P plus Q plus R, oh wait, hold on. Oh, R should be negative of this. So just negative everything, right? So R is actually negative 23. So remember when doing betas, always be careful about the signs. And therefore, we get that P plus Q plus R equals negative 14 plus 52 minus 23. Right? And you should get that the answer is 15. Any questions or anything, comments?